Now finally, we have Daisy Ginsberg. You might have noticed that all of the speakers so far have been in the commercial context. So we thought that we'd balance that out with Daisy, who does a lot in academia. She specializes in synthetic biology. She's a designer, she's an artist and a writer, and she also won last year here at the Design Festival the London Design Medal for Emerging Talent. Daisy.
So now I'm going to challenge the brief and also stand at the lectern. I took this off the website yesterday. The Global Design Forum aims to challenge bad design and inspire new thinking about the kind of great design which makes the world a better place. Apologies to Sir John Sorrell for starting with this, and then because I wanted to ask some questions about it. A better place, a better world, a better future. We assume that design and technology will make things better, but what do we mean by better? Longer lasting, cheaper, more sustainable, more high-tech, more pleasurable. Better for whom? Whose better ultimately shapes our common future? A wise man who's already been mentioned once said we can't solve problems by using the same kind of thinking that we used when we created them. And yet we keep on doing the same kinds of things with design, problem solving. Now, engineering is about problem solving, but design is about possibility. Design projects into our future, making new things out of existing matter. Yet designers like to describe themselves as problem solvers. And I believe we need to do much more than just solve the problems that others bring to us. I think we need to challenge those problems and ask different, more relevant questions. Instead of perpetuating unsustainable systems, we need to actually use design to affect the direction technology takes and get back to this idea that design can alter our future. So this is what I'm doing in my practice, working collaboratively across many disciplines and asking, can we use design to actually question what we're making and why we're making it? So let me explain a little bit about one emerging technology I'm working in. So this is a plate of bacteria engineered by undergraduates for something called the International Genetically Engineered Machine Competition, or IGEM. This was done a decade ago. They go dark when they're exposed to light, like photographic film, and they called it e-Polaroid. So watch out for the bio puns as they come. This is an early example of something called synthetic biology, which is essentially a new approach to genetic engineering, as scientists and engineers attempt to transform biology and life with it into a 21st century design and engineering discipline. We're being told that it will solve our problems and make the world a better place, but through the production of materials, energy, novel medicines and food. Is this a future design discipline? Well, that's a much longer talk that I'm not going to get into, perhaps. But what's being designed at the moment follows what has come before: fuel for planes, rubber for tires, non-biodegradable plastics for products. What's promising to be a disruptive technology is actually also promising to disrupt nothing. So this is a new field with little precedent for what design is or what its role is, and that's why I think it's such an interesting place to shape that and to ask new questions about what does it mean to design better and how we might do that. So I'll give you two examples of projects. So this, another IGEM competition entry from 2009, when 7 undergraduates from Cambridge engineered bacteria to produce this spectrum of colours. It says a summer's work. It's amazing. They called it e-Cromy, and I worked with another designer with the team to get them to think about the laws, the services, the users, the end results of something that might, of an invention like e-Cromy. What unexpected outcomes could they be? We wanted to bring the social implications into the engineering design cycle, so that applications, implications could become inseparable. And here's just one example from this process. We imagined that by about 2039 it might become culturally acceptable to buy yogurt containing genetically modified E. Cromy bacteria at the supermarket. The engineered bacteria drink them, they'd colonize your gut, and if they detected the chemical signals of a wide range of diseases, they'd start producing the corresponding colored output, signaling a visit to the doctor. Yes, finally a laugh. some coloured poo. This we called the scatalogue, and we actually took it off to MIT and caused lots of trouble. So synthetic biology is portrayed as an engineering discipline with machine cogs and computer parts, using those analogies. But in reality, life is unpredictable, it's messy, it's complex. It's ultimately biological. And if we don't want this as our biological future, then what do we want? I'll finish talking about another project I've been part of since 2010, Synthetic Aesthetics, where we brought these kinds of questions to the heart of synthetic biology to labs and studios around the world, pairing 12 artists and designers and synthetic biologists together in these reciprocal residencies, and we asked them these questions. Can you design nature? How do you design nature? And how might you design it well? These are not the kinds of questions that get asked in labs normally, and I'll give you very briefly a taste of 3 projects. An architect and a plant scientist reimagined the biological computer, which is a concept at the core of synthetic biology. Instead of using DNA as a programming language to make stuff, they actually used the entire logic of the cell as a kind of computer processor to be able to solve spatial design problems for architecture. Designers at IDEO in Palo Alto and San Francisco worked with cell biologists to explore the scientific design process, devising new forms of collaboration that could actually take place between a commercial design practice and early stage science, which is also unusual. This is quite disturbing to me. It opens up big questions about the future instrumentalization of life, and I think that's also a really interesting outcome. And finally, we paired a smell provocateur, Sissel Tollas, with a biologist. They wanted to explore what they saw as a potential conflict between the antibacterial world that we live in and this future that's going to be powered by bacteria. And they wanted to make tangible and physical and experienceable the human microbiome, so the bacteria that we rely on to live. So they did this by making human cheese. The groans in the audience tells me that you agree this is biology out of place. Context is everything. And human cheese, as disgusting as you may think it is, it's actually not. It shows us that design operates in a bigger social, cultural, ethical, and political context beyond the objects we make, and we can't forget that. So all this is explored in our book coming out in March from MIT, and what's so important is that this project was funded by science and engineering, which means that the ideas have been able to feed directly back into the scientific community as well into the arts and design and policy discussions. So I've spoken about how I believe that design needs to challenge the very nature of what society thought were the problems. And I ask, rather than just perpetuate the present, we should be using design to shape our future. Can design help us identify and give form to alternative understandings and ideals for the future? I believe, certainly, that asking better questions will give us better problems to solve. Thank you.